help you automate certificate lifecycle management, making the process more efficient and less prone to errors. And we will dive deeper into the features and benefits of the OCI certificates service. We will start with a service overview. OCI Certificate Service is the private certificate authority manager, and it is a part of OCI security products of the public offering. The certificate authority hierarchy solution offers complete flexibility in designing your certificate authority structure. You can chain up to 10 nodes deep and create as many as 100 CAs to meet your specific needs. Being a fully managed service, OCI takes care of everything, from the initial setup to ongoing management. This includes certificate issuance, revocation, and automatic renewals. For added convenience, certificates can be integrated directly with the services such as load balancer and API gateways. And the Leaf certificates have extended extensions for multiple use cases. And for those scenarios where you required a certificate signed by a particular CA or from any public certificate authority, the service supports bringing your own certificates. This service is aligned with OCI Security First commitment, and it is free to use. Next, let us look at key concepts and components of OCI certificate service. Certificates, as we know, are the digital document that confirms the owner's identity. They are used for many purposes, including TLS or SSL certificates, email certificates, code signing certificates, and many more. Next, certificate authority allows you to create and manage subordinate and leaf certificates. CA bundles are also supported, providing a convenient way to securely distribute multiple certificates and metadata in a single package. With certificate chain validation, it ensures that each certificate in the chain is valid and can be trusted. Additionally, the service offers revocation checking to protect against the unauthorized use of certificates. Next, when creating a certificate authority, the service only accepts hardware security module private key, that is HSM key, provided by the OCI Vault service. The Vault provides an asymmetric key, and that is located in the customer's tenancy. This is the best security posture, as we want to ensure your certificate authority do not get compromised and are always protected. The certificate service itself does not have access to your private keys, ensuring the keys are always secure. And service supports following key algorithms as well as signing algorithm. And of course, this confirms with RFC 5280. Similarly, for certificates, keys are backed by HSM and provided by OCI Vault service. Again, the certificate service does not have access to those keys. I'll use a simple example here where you need a secure connection for resources in OCI. The service allows you to create your own private certificate using the private certificate authority, which is under your control. To generate these certificates, the service will use keys from OCI Vault. The Vault will securely store your keys and ensure that your private keys are always safe. Once your certificates are generated, you can easily connect them to your load balancer or API gateways. And hereafter, you will no longer need to manage them. Instead, the certificate service will automatically renew and maintain them. It makes the complex process simple. Then, for managing certificates, you have three options: manage internally, manage externally, or bring your own certificates. Manage internally is the best option for fully automating your certificate lifecycle management. The certificate authority in your tenancy will generate certificates that can be deployed to your load balancer or API gateways, as shown in our previous example. And after that, renewals and deployments will happen automatically. So once you have done the setup, you do not have to worry again. Next, service also have external manage option that is suitable for the use cases where private key cannot leave the premises or must be on the customer's site. In this case, you upload a certificate signing request CSR, and the certificate authority in OCI will sign the certificate, allowing you to use it anywhere. And of course, it also supports bringing your own certificate for the use cases where you have a public certificate to use. So once you have uploaded and imported your public certificates into the service, it will automatically deploy to your resources such as load balancer. And then you can sign up for OCI events so that you will get notified when that certificate is about to expire. And then you can upload the new certificate before it expires. We have some certificate rules which basically controls when and how often the certificate is renewed. For example, as you can see, we can define renewal interval, the frequency at which the certificate is automatically renewed. And the advanced renewal period ensures that the renewal is completed before the certificate expires. We also have issuance rule, which specify a date after which the certificate authority cannot issue or validate subordinate CAs or certificates. So basically it means CA will not be able to create a certificate after the validity date. Service also have some certificate profiles created for your convenience. It has 4 profiles defined, one of which can be server or a client, and that basically is a good example of mutual TLS. You can also create a certificate that belongs to server side or only to the client side. And also you have option for code signing certificates for integrations. Next, talking about integration, we know that service can integrate with load balancer and API gateways. However, with OCI IAM integration, you can control who and what services have access to your certificate authority, certificates, and CA bundles. Also, OCI audit integration allows you to track certificate usage. Integration with the CloudGuard identifies misconfigured certificate resources and highlight them as a problem in the dashboard. And once configured, service will handle renewals and deployment. You do not have to worry about it. And you cannot delete the certificate if it is associated with any resources. First, the association has to be updated or deleted, and then only you can delete the certificate. This adds an additional layer of verification. It also offers automatic revocation with immediate effects. So this is what the complete lifecycle of the OCI certificate service offers. You can create certificate authorities, certificates, and CA bundles. You can import your public certificates, and also you can update, tag, or delete certificates as needed. Automatic renewals can take place, and you can even set rules to determine how frequently it should occur. You can make any version the current version or revoke certificates if they have been compromised or you no longer want to use them. So that's all about the OCI certificate service. Thanks for your time and see you in the next lesson. Hello and welcome to this lesson to see use cases using OCI certificates. In this lesson, we will explore few scenarios where the OCI certificate service can be utilized to streamline operations. So let's quickly look at them. In the first scenario, you can import your public certificate to OCI certificate service and then attach it to the load balancer, where the load balancer will be able to use your public certificate to set up secure connection with your clients. Additionally, using certificate service, you can also set up automated certificate renewals to ensure that your connections are always secure. As you are using a public certificate signed by a trusted authority, all the clients and users will trust the certificate. No additional efforts is required on the client side, making it suitable for e-commerce websites or any other platform that requires secure communication from consumer users. And if you want to narrow down your scenario to private certificates, then you can create your own certificate authority, create a certificate and attach it to the load balancer. In this case, the certificate will not be trusted by everyone. Therefore, suppose few of them are your employees and you have a control over their devices, you will then install a chain of trust for your private certificate authority. So once a connection is requested, certificate from the load balancer is loaded and verified against the chain of trust installed on your employee's device. In this way, the private certificate can be trusted within a specific group of users, providing a secure connection for internal transactions. In another scenario, you can use the OCI certificate service to encrypt data in transit between different services within your cloud environment. This is a good example of mutual TLS, which ensures that both entities verify each other's identity using certificates. So all communication between services is encrypted and secure, maintaining the integrity and confidentiality of data. Our fourth use case is of code signing. The application developer can sign the application bundle with his own set of keys and generate timestamp and hash values. The same set of keys will be used to generate the certificate. The application along with the certificate and hash values will be shared with the client. Then the client will be able to verify the certificate's authenticity and use the keys to verify hash values. This ensures that application has not been tampered during distribution and prevent unauthorized modification or malwares being injected in your software, providing an added layer of security for your applications. So to wrap up, we have seen how OCI certificates help you set up secure connections in multiple ways. For public applications, you can use trusted certificates. Internally, private certificates or mutual TLS help you secure communication with other entities or within your services. And code signing with certificates help you verify application integrity. So I hope this gave you an overall understanding of using the OCI certificates service. Thank you for your time and see you again. Hello and welcome to this demo on OCI certificates service. In this demo, we will explore how to create and attach certificates to the load balancer using certificates service. We will consider this particular scenario for our demo, where we have two web servers and public-facing load balancer that routes traffic from the internet to the web server. By creating and attaching certificates to the load balancer, we ensure secure communication between client and load balancer. In this case, we will create and attach private certificate, as we want to learn how to handle the certificates service. You can also import your public certificate to this service and attach it to the load balancer. So before you start deploying, some pre-configurations are required, such as creating a dynamic group for certificate service, an IAM policy that allows dynamic group to access keys in the OCI vault. In addition, we will need additional IAM permissions to manage certificates and attach them to load balancer. Once these pre-configurations are in place, we first create a master encryption key in OCI vault. Then proceed to create certificate authority. After certificate authority, we create certificates. And then we create a load balancer and attach our created certificate. So these are the steps that we will follow in our demo. So before we go to the console, we will see the resources I have pre-created for this demo, including a VCN with a public subnet and two web servers. The load balancer subnet is also created. Also, the internet gateway, all security list and route tables are in place. In short, our networking and compute related resources are created. Now we are on the console. Our first step is to create dynamic group for certificate service. For that, we navigate to identity and security, go to domains, and here you can select your domain. I will select the default domain for now, and then go to dynamic group. Create dynamic group, provide the name DG certificate authority, and add rule resource.type is equal to certificate authority. This adds our certificate authority to the dynamic. Next, we need to add permissions. I have already added all the required IAM policies for this particular demo. Here you can see the permissions for managing instances, VCN, vaults and keys, as well as for our certificate service, and also permissions for our dynamic group to access keys in the vault. Next, we will quickly create OCI vault and master encryption key. Go to Identity and Security, OCI vault, and create a vault. Provide name OCI cert vault and create it in our demo compartment. Create vault, and once our vault is created, we will create master encryption key. Create key in our demo compartment. Key type will be HSM and provide the name cert master encryption key 1. Select an asymmetric key algorithm with a key length of 4096 bits. Now we move ahead to our certificate service. We will navigate to overview page of the service, and here you can see we have options to create root certificate authority, subordinate certificate authority, and then create our certificate. You can also import existing certificates if needed, or you can import a complete CA bundle. We will go ahead and create our certificate authority first. I will create it in our demo compartment. Here you can select root certificate authority or subordinate certificate authority. As we are creating it for the first time, so we will select root certificate authority. Hereafter you can create the subordinate CA under this root CA. I will provide the name root OCI CA1. Next, the common name. It will be displayed on your certificate, so you can decide what you want to provide here. I'll keep the same name for now, and you can also add additional information for your authority. And then click Next. Here you need to enter not valid before and not valid after to define start and end date for the certificate authority. Then we provide our vault and HSM key information and select a signing algorithm. Next, we define expiry rules for certificates and subordinates under this CA. Then you can provide the object storage information for the revocation list. I'll skip this for now and go ahead and create our certificate authority. The work request will be submitted and our root certificate authority will be created in few seconds. Once our CA is ready and active, you can create certificates. Issue certificates, create it in our demo compartment by internal root CA, and the cert name will be OCI cert1. Next, the common name, I'll keep the same. You can add additional information. Then we select certificate profile type. I'll select TLS for server and client. The issuer will be our certificate authority we created, and the certificate not valid after specific date. Select key algorithm and next. Here we set some rules by providing the frequency to renew, and it will be renewed 30 days prior to expiry. Review the details and now create your certificate. Certificate will be created in few seconds, and then we will attach it to the load balancer. Now we will quickly go ahead and create our load balancer. Networking, load balancer, and create load balancer. Provide name, load balancer for cert demo, keep all default, select the VCN and the subnet created for load balancer. Select our backends and keep HTTP protocol for health check. You can even use SSL and provide the details like you want to use certificate service or you want to directly upload it on the load balancer. With certificate service, we can provide CA bundle or provide certificate authority information. For now, I will not use SSL for our backend, and we go ahead and create our listener. Here we will select our certificate service and the certificate that we created. Next, I will enable the default log group and create our load balancer. It will take some time and then it will be active. You can use the public IP address and verify the certificate associated with load balancer. Verification can be done in multiple ways, but the simplest way is to go to your web browser and enter the public IP address of load balancer with HTTPS protocol. Since it is a private certificate and not trusted on the open network, we need to accept the risk associated with this certificate, and then you can view and confirm the certificate details. Additionally, by adding chain of trust to the devices, you can recognize and accept private certificate as a trusted entity. So to wrap up, in this demo, we got to know how to create and attach private certificates to a load balancer using OCI certificates service. For that, we first created OCI Vault and master encryption key. Then we created private certificate authority and then our certificate. After that, we attached that certificate to a load balancer. Finally, we verified the associated certificate using web browser. So I hope this was helpful. Thanks for your time.
Hello, and welcome to this new lecture on the Web Application Firewall. These are the topics that we're seeing today, and we are breaking this lecture in 2 video recordings. So first, we're going to cover why the Web Application Firewall, the OCI WAF architecture, and use cases. In the second section, we'll see the Web Application Firewall service components, benefits of OCI WAF, and the workflow to enable WAF in your application. And after we're done, we're actually doing some labs, pretty cool labs. We'll build a policy that will block access into your website based on the origin of the client trying to access your services. So the multiple layers of defense, these two, they're self-explanatory. Oracle's built around multiple layers of defense. Data security is core. And these multiple layers of defense include security at rest, during transit, and security when access or use of your data or application. This is where the Web Application Firewall comes into place. When a web server is exposed to the internet, you want to make sure that your website is protected against bad actors who wants to compromise your site. The Web Application Firewall is a solution that helps protect websites against attacks that cause or could cause downtime or data breaches. The WAF acts as a reverse proxy that inspects all traffic flows or requests before they arrive to the web application. It also inspects any requests going from the web application server to the end user. Most of these attacks are based on custom scripts that explores vulnerable points of your web application. So when the WAF recognizes one of these requests, these attack requests, it can perform some actions. It can block the requests and can respond with error page. It can challenge the request to make sure that it's a human, or depending on the level of attack, you can decide to let it pass through, or you can log in that request. The OCI WAF is a cloud-based solution, PCI compliant, that protects your applications from cyber attacks. That's basically it. The OCI WAF can protect any internet-facing endpoint hosted on OCI, on premises, a combination of both, or elsewhere. It will intercept HTTP and HTTPS traffic and passing them through a set of filters and rules. And we'll take a look at those filters and rules once we build our policies. And these rules cover common attacks such as cross-site scripting and SQL injection. Let's take a look at the architecture. As I was mentioning, your solution does not need to reside on OCI for the Web Application Firewall to protect it. It can also be your on-premise solutions or a combination of both. The WAF points of presence, we have 22 all over the world. Here you can only see 17. For more information, go to this website. Actually, I have it open. So go to the frequently asked questions, and you can see all of the details where we are, where the points of presence, and how it behaves. So I do recommend going through that website. So the use cases for OCI, Web Application Firewall, it also provides aggregated threat intelligence from multiple sources, including WebRock and BrightCloud. Onboarding your application to the Oracle Cloud Infrastructure Web Application Firewall will protect against Layer 7 distributed denial of service, or DDoS attacks. The OCI Web Application Firewall utilizes the Open Web Access Security project to keep the 250 predefined rules always updated with the latest attacks available today, or the latest protection against attacks that are available today. How it works is that these rules are compared against incoming requests to identify if the request contains an attack payload. And if that's the case, then the Oracle Web Application Firewall will block or send an alert about that request to the person in charge, to the system administrator. And we'll take a look again of all of these injections, all 250 of them. So we will continue our presentation on the next lecture, and see you there. This concludes this portion, the first part of the lecture. See you there. Hello, welcome to part 2 of the Web Application Firewall lecture. My name is Sergio Castro with Oracle University. And at this part 2, we are seeing the components, the Web Application Firewall service components, and the benefits of Oracle Cloud Infrastructure Web Application Firewall. You got a lot of acronyms. And we'll see the workflow to enable WAF in your application. So the web service components, the WAF policies, origin, protection rules, and bot management. So let's take a closer look at each one of them. The WAF policy covers the overall configuration of your web application firewall service, including the origin management, protection rules settings, and bot detection features. Now, the origin for your web application must be defined in your WAF policy. So this is basically your application, your web server. The protection rules can be configured to allow, block, or lock network requests to your application. And obviously, you're going to set certain criteria for those protection rules. The web application firewall will serve traffic to your server and suggest new rules to apply. The bot management, the web application firewall service includes several features that allow you to detect and either block or allow identified bot traffic to your web application, basically good bots. The bot management rules include JavaScript challenge, CAPTCHA challenge, and the good bot whitelist. The origin management is an endpoint protected by the WAF, regularly an IP address to the application, or in some cases, a load balancer in front of your application. Multiple origins can be defined, but only a single origin can be active on your web application firewall. The WAF protection rules match web traffic to rule conditions and determine the action to be taken when the condition is met. The access control rules, you as the web application firewall administrator, you can define explicit actions to be taken. Conditions use various operations and regular expressions. And a rule action can be set to lock and allow, detect, block, redirect, or show a CAPTCHA. you can also have IP address whitelist. Bot management enables you to mitigate undesired bot traffic using CAPTCHA and JavaScript detection tools. Bot Manager is designed to detect and block or redirect non-human traffic that may interfere with your operations. Basically, bots can act as a denial of service attack. Basically, if you have many go into your site. So basically, you can mitigate that by challenging and making sure that before presenting the information, the client is a real human, a human being. Now, caching rules, we have several of them that you can use as criteria, like your URL is, URL starts with, URL ends with, URL parts contains, and then you can have actions based on this. The WAF has several sources of known IP addresses threats that you can use to gain intelligence from it. Now, the web application firewall is a shared responsibility model. Some actions are managed by Oracle and some are not. For example, you can configure your web application firewall dependencies, and that's done by you. This is the part that you manage. Now, Oracle managed the constructing of new rules based on known vulnerable points. And we also, Oracle Cloud Infrastructure, also keep the WAF infrastructure patched and up to date. So that's a responsibility. So basically, maintaining it is part of responsibility for Oracle, and using it and configuring it to your own likings is yours. We mentioned that we have 250 cross-site scripting rules that you can utilize to mitigate attacks. It's not recommended that you use all 250 of them, because then the quality of service that you're providing to your clients will not be optimal. So there's a rule that you can select based on the application that you're utilizing. So the benefits of the Oracle Cloud Infrastructure Web Application Firewall, it consolidates intelligence, push malicious traffic further away from your origin, basically kicks them out, better visibility into internet traffic metrics, and obviously better quality of service to your end users. And it's low cost. This is really important. Now, in order for you to be able to, or the WAF administrator, these are the policies. If the user doesn't belong to the overall system administrator, then you can restrict in a fine-grained detail the policies for the WAF administrator to manage the WAF policies on your behalf. Make sure that you can take a screenshot of this slide or come back to it. So getting started with the web application firewall. These are some pre-requirements. If you have the private keys, then make sure that you can use them. If you have a certificate, you can go ahead and use them. It's not a requirement. We also work with port 80, so you don't need a certificate for that. And we are going to be doing an example using port 80 today. So these are the steps. Basically, go into the secure your web application firewall, create the policy, update the origin, and make sure that it's keep alive, that you specify the timeout, update the DNS to enable WAF. We are going to be providing you a key once you set up the policy that you need to take to your DNS and update the records with this key or with this certificate, and then test your application. And probably you're itching to go into the demo. So am I. Thank you for attending this lecture, and see you in the demo. Hello, and welcome to this new demo on load balancers and web application firewall policies. It's a new feature that you can assign from within creating the load balancer, a web application firewall. And also from the web application firewall, you can select an existing load balancer if you wish to do so. So let's go ahead and take a look to see what is it that we have right now. So as you can see, I am in my tenancy, and currently I'm in the Germany Central region, which is Frankfurt. And as you can see, I have a Windows virtual machine, and this is the IP address. So the reason why I have this is because we're going to be creating a load balancer, and we're going to be accessing that load balancer from the US, which is where I am right now, and also from this Windows instance in Germany. And here it is. As you can see, the IP address is the same one. So I'm logged in via remote desktop connection. And let's go ahead and see what else that I have on my tab. Here, as you can see, I have all of these policies that are being deleted already. Let me go ahead and change the state to the active ones. We're going to be creating a web application firewall. But before we do that, we are going to take a look at our load balancers. I don't have one, so let's go ahead and create a load balancer. And the new feature is assigning a web application firewall while you're creating the load balancer. In this case, we'll create two. The first one will not have a web application firewall because we don't have one yet. As you can see, I don't have one in neither one of the compartments that I'm working with. So, and then the second one, we are going to be creating web application firewall and then assigning it to the load balancer. So let's go ahead and create the load balancer. We are going to be using the one that has layer 7. And let's go ahead and create it. And I'm going to call this is a demo, so I'm going to call it demo. Public. We are going to be allowing the ephemeral IP addresses. Now, the web application firewall policy applies to flexible shapes, not to the dynamic shapes. So we are going to be using the flexible shapes. And in the case that you want to select the web application firewall, you click on the advanced options and select it from here. In this case, we don't have one yet. So let's be a little bit patient and create this one first. So this is my virtual cloud network. So you can see this is the one that I created for SSL in VCN and my public subnet. And I'm not going to click on this one. So let's go ahead and click next. Let's go ahead and add the backends and add both of them. So these are the backends, the health check policy. And I'm going to be working with HTTP. And I'm going to skip the error logs for the time being. So I am submitting and I'm creating the load balancer. The load balancer is active and healthy. So let's go ahead and copy this IP address and see it working. So I'm in the US. I'm going to access from the US. And here it is. As you can see, I'm in server 1. If I refresh, I go to server 2, so on and so forth. Now let's go to Germany and try it as well. Same address. And it's working. So let's go ahead and create the web application firewall policy. So I'm going to call this also demo. And in this case, we're working out of the testing compartment. I believe that's the compartment that I selected here. And what compartment am I in? Testing. So let's go ahead and do that. Keep it in the same compartment. Now, these are the actions that I have. Check, allow, and detect. And right now, I don't have any rule, so we are going to go ahead and create the rule. And I'm going to enable access control and add the access rule. In this case, I'm going to call this US and select the condition. In this case, it's going to be country. And in the list, I'm going to select United States. And here it is, United States. Now, what rule action that I want? I want this to block. Well, this is the response that I'm going to be sending. And you can see it right here. This is going to be the response that you're going to be getting. And the content is application JSON. So I'm adding the rule. Now I need to add the action as well. And the action, to be consistent, is block. Here you can see the control options. And you can add additional rules if you want. In this case, I'm using the default values. So I'm going to click on next. You can enable limiting by rate. And here you can add your rate limiting rule, but we're not doing that right now. And you can also work with protections and configure your own protection rules, the cross-site scripting and all of that. Here it is. So, but we're canceling this because we're working with access control at this moment. And here's where you can select your load balancer. And for some reason, it thinks that I'm in training, but we're in testing. And we're going to be selecting the load balancer. And I'm going to go back into the access control because I didn't add the allow Germany. So in list, in this case, is Germany. Here we go. And the action is allow. And the default action is going to be allow. Now I have my two rules right here, and I can go ahead and continue where we were at and create the web application firewall policy. And it's being created right now and waiting. We're alive, so let's go ahead and see. This immediately should work. There it is. Took a little while, but it's enforced. So let's go ahead and test Germany. You see, it didn't affect this at all. So let's go ahead and reverse the order. So we are going to go back to firewalls, and access control is what I meant. Now I'm going to manage this. And now I'm going to change the action. And here I'm going to allow. It's this one, allow. Change the action. And this one I'm going to block. And save the changes. And as you can see, this was quite fast. So let's go ahead and test it. So now it should allow me. And there we go. Now in Germany, it should block me. And there it is. So this is the first part of the lab. Now let's go ahead and create another load balancer. In this time, we're selecting this web application firewall that we created. So I'm going to call this another demo. Same backends. And am I missing something? Yes. I didn't scroll down. I'm going to create it here. Now, Show advanced options. I was missing the most important thing. This is my web application firewall. And click on next. Click on next. Configure the listener HTTP. No error logs. This is the new load balancer IP address. This is the one. Another demo. Let's go ahead and copy this. And again, it should work here in the US because we reversed the policy. And here we are. Server 1, server 2, server 1, server 2. Let's go to Germany. And here we are. And not authorized. This completes the lab.
Hello and welcome to this lesson on OCI Key Management Service, also called as OCI KMS. This is a cloud-native service that provides centralized management and control of encryption keys for data stored in OCI. Now, when you look at the cloud infrastructure or layers, you have the core infrastructure, then data and database related services, and on top you have applications. And if you notice, security is essential at every layer to ensure the protection and privacy of your data. In that sense, OCI KMS helps to ensure that encryption keys are securely managed and protected. By centralizing key management, organizations can have greater control over access to sensitive data, helping to minimize the risk of unauthorized access or data breaches. Overall, key management in the cloud infrastructure helps to create a robust and secure environment for data storage and management. For example, when an organization stores sensitive customer information in OCI, they can use the key management service to encrypt the data at rest and control access to the encryption keys. This ensures that even if a malicious actor gains access to the data, they cannot decrypt it without having proper keys. Considering this, OCI KMS simplifies key management by centralizing the storage and management of encryption keys. It offers various encryption key types, including symmetric and asymmetric keys, to protect your data at rest and in transit. Under OCI KMS, we have several services intended to meet different encryption needs. First, we categorize them into Oracle managed keys and customer managed keys. Oracle managed keys are automatically generated, rotated, and stored by OCI, providing convenience and security for users who do not want to worry about key management. As part of a security-first approach, everything is encrypted by default with Oracle managed keys to ensure that sensitive data is always protected. Customer managed keys, on the other hand, allow users to have more control over the encryption keys. Let's start with OCI Vault, a customer managed encryption service. With OCI Vault, you have control over your encryption keys, while Oracle controls the hardware security modules on which keys are stored. There are two options: Virtual Vault and Private Vault. Virtual Vault is a multi-tenant encryption service where keys are stored in HSM partitions that also host the keys of other customers. It is the default encryption service and offers cost-effective key management. Private Vault, on the other hand, provides a single-tenant environment for your keys, offering enhanced isolation and control. Next, we have OCI Dedicated KMS, a single-tenant HSM partition service. It offers a fully isolated environment for storing and managing encryption keys. With Dedicated KMS, you have complete control over the HSM partitions, ensuring maximum security. The key difference between Private Vault and Dedicated KMS lies in the control of the hardware security module partitions. In Dedicated KMS, you gain full control and ownership of these partitions. This means you can utilize standard interfaces like PKCS number 11 to execute cryptographic operations granting you greater flexibility and customization. However, it is important to note that while you have control over the HSM partitions, Oracle continues to administer them for security measures like firmware patching and overall system integrity. Next, OCI External KMS allows you to integrate your third-party key management system to protect your data in OCI. You maintain complete control over the keys and external HSMs, and your master keys are always stored outside OCI and never imported into KMS. So the encryption and decryption happen outside of OCI. This is needed in use cases where we have compliance to have keys on-prem. We will go in detail in each of these services in following lessons. Next, here we have a table to compare OCI KMS offerings. Starting with tenant isolation, we have services that provide both multi or single tenant option. Then there is customer control over keys and HSM. And as you can see, we have control over keys in the OCI vault. And with dedicated and external KMS, you have control over both keys and HSM. The vault supports both HSM and software keys, while dedicated KMS support for HSM-based keys. In terms of integration, all offerings have seamless integration with OCI services, with the exception of dedicated KMS, which uses a standard interface to connect. You can have different use cases and limits associated with each offering that fulfill various security and compliance requirements. For example, the multi-tenant option may be more cost-effective for smaller businesses, while the single-tenant option provides added security and customization for larger enterprises. Additionally, the ability to control keys and HSM provides customer with peace of mind by ensuring that their data is secure and only accessible to authorized users. In the following lessons, we will go over each KMS service in greater detail, including OCI Vault, dedicated KMS, and external KMS. Now the question is, how do you select the right OCI KMS offering for your organization? To ensure the best fit for your organization, consider the level of control your organization needs over encryption keys and the level of security required to protect sensitive data. For example, from a security point of view, if you need a single tenant and key isolation is very important, then opting for an OCI private vault or dedicated KMS may be the best choice. On the other hand, if your organization is smaller and budget is a concern, a multi-tenant option may be sufficient as long as the level of security meets your compliance requirements. But if compliance needs to have your keys on-prem, then an external KMS is the best option for your organization. And if you look at the cost factor, OCI Virtual Vault is the most cost-effective option for customer managed encryption. OCI dedicated KMS and OCI external KMS are more expensive but help enable customers to meet unique requirements relating to control over encryption keys and HSMs. Before we conclude, let's look at the benefits of OCI KMS. With simplified key management, OCI KMS centrally controls the storage and management of your encryption keys, making it easier to keep track of them. And for data protection, it supports various encryption key types, including symmetric and asymmetric keys, to protect your data at rest and in transit. To ensure control and compliance, OCI KMS provides several options, including bringing your own keys to OCI or creating keys directly in OCI. Additionally, the Hold Your Own Keys option employs external key management systems. It also uses FIPS 140 at level 3 certified hardware security modules to ensure the highest level of security for your keys. For integration, you can easily use your encryption keys with other OCI services related to storage, databases, and applications to safeguard your data. So overall, OCI KMS provides a flexible and secure solution for managing encryption keys. So to conclude in this lesson, we got to know how OCI KMS centrally manages encryption keys and offers different services for various security and compliance needs, ensuring your data is secure and controlled. We will go over each service in more detail in the following lessons. Thanks for your time. See you in the next lesson.
Welcome to this lesson on OCI Vault, where we are going to look at some of the OCI Vault basics. OCI Vault is a managed service that lets you centrally manage encryption keys and secret credentials. It supports various algorithms like AES, RSA, and ECDSA algorithms. We looked at some of these in the basics of encryptions, the previous lessons. Several OCI services integrate with the OCI Vault service. And primary concepts on the Vault service which you need to understand are the vaults themselves, keys, and secrets. And we have lessons for each of these. We cover each of these in subsequent lessons. Now, the whole idea of Vault is you can centrally manage encryption keys and secret credentials. And the idea is Vault removes the need to store these encryption keys and secrets in configuration files or in code. So it's kind of a best practice. You should use a service like OCI Vault, and then it helps improve the overall security posture in your organization. So let's look at each of these concepts in greater details, starting with vaults. So vaults are nothing but logical entities where the vault service creates and durably stores keys and secrets. Now, when you create vault, depending on their kind of two protection mode, we'll talk about those. Keys are either stored on a server or they are stored on these highly available and durable hardware security modules called HSMs that meet the FIPS 140-2 security level 3 security certification. That's kind of a mouthful, but think about this as kind of one of the highest independent assurance that the design and implementation of the product and the cryptographic algorithms behind it are pretty sound. So this is kind of internationally recognized standard. So HSMs are used to durably back up these keys inside the vault. Now there are two kinds of vault, as we discussed, as I just talked about, right? The first one is called virtual private vault. So think about this as a dedicated isolated partition in an HSM. So you take an HSM, you create several partitions on them, and the virtual private vault is basically your own dedicated partition. And as a result, you can store up to 1,000 key versions. We'll look into what key versions are. You have a better isolation, of course, right? Because it's dedicated to you. And one advantage with a virtual private vault is you can back up the vault and the keys to object storage, so they can really be helpful in disaster recovery scenarios and cross-region replication, etc. So think about these as kind of more advanced version of the product. And then there is something called a shared partition. So you take one partition and then the same partition is shared with multiple tenants, with multiple customers. It's still quite secure, but as a result, you don't get some of the benefits. You cannot back up to object storage, and you get charged for the number of keys and the key versions and the secrets which are stored. And we'll look into this as we go into the console. We'll do a quick demo. Now, what are keys? Well, keys are logical entities that represent one or more key versions, each of which contain cryptographic material. We saw what keys are in the previous lesson on encryption basics. Keys encryption cryptographic material is generated for a specific algorithm, either AES, RSA, or ECDSA, and that lets you use the key for encryption, either for encryption or decryption or for digital signing. Now, in the Vault service, basically there are three kinds of keys which you need to care about: the master encryption keys, data encryption keys, and the wrapping keys. And we'll look into each of these in greater detail. So let's start with master encryption keys. What are these, right? And we'll look into data encryption key as well. So master encryption key, just kind of because it's mouthful on the slide, I have kind of shortened it to MEK. People also refer to as master encryption keys. So the idea is these are the keys you create or import in the vault. MEKs are used to generate what are called as data encryption keys. We'll look into why that's the case. Master encryption keys are always created in a vault, and protection mode, there are kind of two protection mode, indicates how these keys persist and where cryptographic operations are performed. So when you talk about vault and you talk about keys, pretty much every time you're talking about master encryption keys, right? These are the keys which you use to encrypt and decrypt, but you will see that it's actually behind the scenes a little bit more complex. So there is also this concept of data encryption keys, and data encryption keys are generated by the master encryption keys, and these are used to encrypt data. Data encryption key themselves are encrypted with master encryption key, and this is known as an envelope encryption. And you will see, why envelope encryption makes sense in subsequent lessons. But the idea is the OCI services like block storage or file storage, they don't have access to the plain text data encryption key. I mean, they have access, but they use it for encryption or decryption, and they remove it from memory as soon as possible after usage. So this is what is being shown on the graphic on the right hand side. So as we said, when you talk about key, most of the time you're referring to as master encryption keys. These keys are generated, always created inside a vault, and depending on the protection mode, sometimes you cannot even export them outside the vault. And what the master encryption key does is it generates this thing called a data encryption key. And as you can see here, data encryption key is kind of plain text key, and then it also encrypts the data encryption key, and it sends it to the different services. The services use the plain text data encryption key to do encryption or decryption, and then they remove it from memory as soon as possible, and store the encrypted data encryption key as as part of their storage. And we'll look into that in a subsequent lesson, but you can see how this kind of data encryption key is itself encrypted with a master encryption key, and that process is called envelope encryption. And we'll look into this in a quick demo. So let's look at this, and then I'll switch over to the console and we'll do a quick demo. Now, master encryption keys can have one or two protection mode. The first one is called HSM, and as we talked, these keys are durably backed by highly available and durable HSMs. So when you choose this HSM protection mode, the keys, as you can imagine, are stored in an HSM. They cannot be exported from HSM, and all cryptographic operations happen inside HSM. So this is like the most secure kind of environment you can get. The second option is called what we refer to as software. In this case, the master encryption keys are stored on a server. They can be exported to perform cryptographic operations. Obviously, they're stored on a server, but they're protected while at rest, and they can be encrypted by a root key on HSM. And there are different kind of pricing mechanisms, whether if you want the keys to be stored on HSM or you want the keys to be stored on software. With that, let me switch over quickly to the console and run through a quick demo. Alright, so I'm in the console here, and if I click on the menu on the left hand side, I can bring up identity and security, and then Vault is right here as part of identity and security service. I'm logged into the US West San Jose region. Vault is a public service, and it's a regional service, so of course I can create vaults in different regions. Now I already have a vault existing here. Let me just quickly go ahead and create a vault. So I already have a vault 1, so let me just create a vault 2. I'm creating this in the US San Jose region, so I'll just do that, right? And as I'm doing this, right, you can see I need to choose a compartment, of course, and I can make this a virtual private vault, and this creates the vault as a dedicated partition on the HSM, and their pricing and other criteria here you could click here. So if I click this, check this box, it basically creates a virtual private vault. I'm not going to do that, so I'll just click create vault here. And now what you will see is the vault is getting created. As that might take a couple of minutes, let me just go to this vault which already exists. Now you can see I have certain keys which I have created here, right? So to create a key, it's again pretty straightforward process. I click on create key here, and as I do that, now I can see the two protection mode. There is HSM and there is software, and it says basically the protection mode determines how the key persists and where cryptographic operations are performed, right? So let me just choose software first, and I need to I would say this is give a name. I'd say this is my first key, and I could choose my algorithms here, right? AES, RSA, or ECDSA, right? And if I choose AES, I get a choice between 128, 192, or 256 bits. I could choose 256 here, right? And I can click create key here. So now this key has a protection mode of software. You can see here, and I could as well create a key which has a protection mode of HSM. Now the price you have for that HSM versus software is different. and I could choose another key algorithm here. I'm just going to leave AES, and I choose HSM, and I can create another key here. So this is how simple it is to create a vault and create these keys. And again, as I said, master encryption keys, when you say, basically means the keys which are used for encryption and decryption. Behind the scene, it uses data encryption keys, but that's not exposed right here, right? And my second vault is also created. I can go ahead and create a key here as well. So let me switch back to the slides and complete the remainder of this lesson. All right, so we looked at how easy it is to create a vault and create keys, whether they are backed by, protected by HSM or by software. We saw this in a quick demo. The third kind of key which Vault Service recognizes is called wrapping keys, and wrapping keys included with each vault by default. And the whole idea is you use the public portion of the wrapping key pair when you need to wrap key material for import into the Vault service. So for example, you want to import keys within Vault, and Vault supports import. You need to wrap them in the public wrapping key, and Vault has access to the private wrapping key, so it can unwrap it and it could use it. So it just makes it more secure. As you're transferring the key to the Vault service, you can use the wrapping keys for that particular purpose. Now, every vault has a wrapping key. You cannot create, delete, or rotate wrapping keys. So keep that in mind. When you create a vault, you can see this wrapping key information here on the left hand side. You can see, right? And the way it is used is I'm creating a key here, but I'm importing an external key, right? I'm not creating this key within the Vault service. And when I check this box, import external key, now you can see I have to use the public wrapping key. And remember, Vault has access to the private wrapping key, and that's how it gets key which you import, it can use within HSM, and it's, it's secure, etc. All right, so let's look at the last part of this lesson, which is around rotating keys. Now, as we discussed, each key is automatically assigned a key version when you create a key for the first time. When you rotate a key, a new key version is generated. Periodically rotating key limits the amount of data encrypted or signed by one key version. It's kind of a best practice, and it reduces the risk if a key is ever compromised. Now, you might be wondering, if we rotate the key, how does the Vault service figure out decryption? For example, if encryption was done with a different key version. Now, the behind the scene, the key's OSID remains the same across rotations. So older versions cannot be used for encryption anymore, but they can be used to decrypt data which was previously encrypted with it. So let me quickly show this on the console, and then we'll conclude this particular lesson. Alright, so I'm logged into the console. As you can see, I'm using the vault which was previously created, and I created these two keys, my first key and my second key. So if I go to my first key, you can see, if I click on versions here, you can see I already have a version which got created when I created the key here, right? As you can see here, if I click on, so if my first key is here, if I click on rotate key, and I don't want to import external key version, just click rotate key here. So it will create a new version of this particular key, and now it gives me this this kind of text here, which says that cryptographic operations involving objects that were encrypted with a previous version of this key will continue to use the older key version. You can re-encrypt those objects with the current key version if you prefer, right? So it gives me that, and now I can see my previous versions and the current version here, right? So this is how easy it is to rotate the keys, and hopefully that gives you a good idea of kind of a security best practice we need to follow. So hopefully this was a good lesson on quick intro to OCI Vault service, and we looked at the key concepts around vaults, keys, how easy it is to create vaults and keys, and then when you create these keys, how easy it is to rotate these keys. Kind of that's a kind of a security best practice. I hope you found this lesson useful. Thanks for your time.